Welcome to class, everyone. Go ahead and grab a seat. I am absolutely thrilled you're here with us today. We are going to dive straight into an explainer that really serves as your master syllabus. As someone who's guided countless students through this exact journey, I want to share a rigorous 4 to 7 year operating system that is designed to build your engineering brain completely from the ground up. Now, it definitely requires discipline, but stick with me because I promise to guide you step by step. Here is our syllabus for today's explainer. Escaping Tutorial Hell, the Engineering Maturity Map, Mastering Mental Models, Coding in the AI Era, Projects over Passive Learning, and finally, the Elite Engineering Philosophy. I know, it sounds like a lot, but don't let the scope intimidate you. We are going to conquer this roadmap together. All right, Section 1, Escaping Tutorial Hell, Unlearning Bad Habits. So before we can learn the right way to do things, we really have to unlearn the bad habits that end up wasting years of our potential. I want you to honestly ask yourself right now, are you stuck in tutorial hell? You know the feeling, right? It's when you just absorb information without actually producing anything yourself. The brain simply doesn't encode it that way. Are you bouncing from C to Python to Java, getting this really superficial knowledge of 8 different languages, but achieving true mastery of 0? That right there is the fundamental disease of breadth without depth. Just look at the average student trajectory. It usually involves panic learning some shot full-stack framework via a 12-hour video, building a clone of a clone, and then confidently calling yourself a full-stack engineer. But then, well, they get a job and realize they don't actually know how anything works underneath it all. The right sequence completely inverts this. It's all about deep fundamentals, sequenced mastery, and compounding your knowledge over time. And doing that requires a strict maturity map. Each stage has to compound on the previous one. In all my years of teaching, I emphasize this to every single one of my students. You must absolutely resist the temptation to skip stages. The most exceptional engineers you read about, they didn't skip the basics. They just completed each stage at a much, much higher resolution than their peers. Moving right along to Section 2, the Engineering Maturity Map, Building the Foundation. Those first 15 months of your journey are absolutely critical. You're going to start at stage 0, computational literacy, where you write tiny programs with 0 libraries just to understand what a computer actually does. Next is stage 1, which is deep mastery of a single language, like Python. But stage 3, well, that's where my students face the real crucible. That's implementing fundamental data structures from scratch in a low-level language like C. Python already is a hash map, right? But implementing one yourself in C, that teaches you everything about how memory actually works. Which brings us to Section 3, Mastering Engineering Mental Models, Thinking like an Architect. Once you have those core foundations down, you'll realize something pretty profound. Syntax can simply be looked up on the fly, but mental models? Those have to be installed directly into your brain. We need to throw away the old classroom metaphors right now. A variable, for instance, is not just a little box that holds a value. No, it is a name bound to a memory location, and the language decides what that means. Understanding that fundamental difference completely changes how you debug, how you view pointers, and how you manage memory in complex systems. And as you grow, you really must stop thinking in just one paradigm. An engineer who only knows object-oriented programming is severely artificially limited. Procedural programming assumes machine efficiency is the hardest problem to solve. OOP assumes managing state and large systems is the hardest. Functional programming, that assumes correctness via simplicity is the hardest. Don't be a paradigm fundamentalist. The elite engineer blends all of these effortlessly, picking the exact right tool for the architectural problem at hand. 1 nanosecond. Let that sink in for a second. That is the staggering speed of an L1 cache read on a modern CPU. In my lab, we teach that understanding these vast latency differences in the memory hierarchy is exactly what separates actual engineers from mere coders. Sure, you can produce working software without this knowledge, but you absolutely cannot produce fast, scalable, and debuggable software without understanding why your CPU cache fundamentally alters the execution time of your algorithms. All right, Section 4, Coding in the AI Era, Amplifying Your Expertise. Look, the landscape is shifting dramatically right now. Code is increasingly being generated and reviewed rather than written entirely from scratch. For you, as future top-tier engineers, this means that reading, debugging, and specifying code is now vastly more important than the physical act of typing it out on your keyboard. So the absolute golden rule of AI-assisted programming is this: never, ever paste code you do not fully understand. I promise you, sticking to this rule alone will elevate you above 80% of developers today. Average engineers use AI to produce code they couldn't write themselves and can't effectively review. Exceptional engineers, though, they use AI to amplify what they already deeply understand, and they meticulously review every single line. Because of this AI revolution, we're experiencing some massive shifts in our field. We are moving from writing implementations to writing crystal clear specifications. We're moving from pure code to overarching systems judgment. Think about it. When everyone can generate code, judging which code to generate becomes your true differentiator. It heavily rewards those who focus on deep system architecture, and it's going to punish those who rely purely on syntax recall. Next up, Section 5, Projects over Passive Learning, Building Actual Competence. To survive and actually thrive through these shifts, we have to acknowledge a hard truth. Merely reading and watching videos only produces the illusion of competence. You don't start off by building a generic to-do app, nope. You start with a CLI calculator featuring a real recursive descent parser, because that teaches genuine engineering. From there, you advance to writing a tiny shell in C to master system calls. Then you move up to distributed systems with a job queue, and finally, you orchestrate local AI retrieval systems. You have to prove and compound your competence at every single level. And finally, Section 6, the elite engineering philosophy, the 40-year horizon. Your window here at the university is incredibly short, but your career in technology, that is a 40-year horizon. I want you to burn this equation into your memory right now. Mastery equals focused hours multiplied by the quality of feedback multiplied by years. You cannot accelerate time, but you can dramatically maximize your focus per hour, and you can actively seek out ruthless, high-quality feedback from rigorous mentors. Elite engineers compound. They invest in their tools, their notes, and their foundational knowledge year after year, decade after decade. So, the roadmap is now in your hands. The tools are waiting for you. Programming is a true craft, and no AI tool will ever substitute for the thousands of focused hours required to build a brilliant engineering mind. The question isn't really whether this path is hard. The question is, 10 years from now, will you be the architect of the system or just the one blindly copying its code? Thank you for joining me for this explainer today. Class is dismissed, and I will see you in the codebase.